I should have actually done that. So now I kind of blew that call. But would you rather have the comment or the points? You should get both, but all things being equal. All right, let me open this guy up. Oh, okay. So let me just see where we left off. We were talking about how to represent our memory, right? And I think we have like a scroll view of edit boxes or something. I'm trying to remember. Did I give you an assignment for that? Oh, because that was right before Thanksgiving. Okay. So I think if we go to memory here, we kind of have a starting point. Yeah, so we have a scroll view of text boxes here, or edit texts. And each of these is a bucket of memory off of a kind of an offset, a base offset. And I think we do 64. Yeah, so we did 64 bytes of memory. So we decided each thing was going to be a byte. And this would then allow us to implement our loads and stores, correct, for putting things into memory and getting things out of memory. So things that would go into memory are going to be numeric. So we can probably change the keyboard here to be the numeric only keyboard. So if we go into this screen here, actually I could just look at it one of my other screens. Here's an edit text. I just want to see what input type. Yeah, I think I need to set the input type of it to. So on our memory screen, we programmatically build that thing of memory. So here is our edit text, our temp edit text. Here we're setting the initial text to 0. And what did I just say the type is? It is input type. So we're going to say temp et dot set input type. So set input type, and this guy is going to be what, input type dot type class number, looks like. See what that looks like. All right, so I'm programmatically setting that property of this input text so that the keyboard that pops up is just a numeric keyboard. Not that huge of a deal, just kind of a I don't know, an approach to this. But one thing, let me make sure it works first, and then I'll point out what I maybe want you to see from this, just from a generalistic programming perspective. All right, so we have a much better keyboard now. I get the negative numbers too, sort of. I kind of need a backspace on there, so it's kind of a bad design, but whatever. How do I make that negative? Kind of a wasted keyboard, it seems like. You can't do it after.
Are there other options for what?
Well, I'm sure there are, but I'm just concerned that there is a minus thing there that doesn't seem to do anything. Yeah, see, we can look at what other types there are right here real quick. So this is number flag signed. Maybe the number one gives me the same keyboard as the one with the minus, but doesn't actually give me the ability to hit the minus. Well, that doesn't look like this is a wasted. class. It really seems like number should be the right one. I'm not going to spend very much time on doing the negative stuff and things like that if I can't get it to work. Oh yeah, I can't even I can't type it either. So it's like it's not allowed on there. But regardless, we'll just do positive numbers right now. I'm sure it'll reveal itself soon. There might be as a flag or something. But what I want you to see here is when I was typing this, so this is my edit text. So if you remember, we created a brand new edit text. We're programmatically doing this inside of onCreate, right? So we're doing something 64 times. So I've given myself 64 little slots for putting stuff into memory. That way we'll be able to load stuff from memory, store things into memory. And we'll also be able to do that offset thing for arrays. So we'll make all that work too. So I create my new edit text here, given my current context. I'm giving it a starting value, this set text to 0. Now, what I had done, I don't recall. At some point, I've probably set the keyboard before. But if you saw me when I was typing this, I was kind of using the command completion to figure out what the code was going to be. So one thing I want to kind of emphasize to you here this really isn't this is more of just a generalistic programming type thing, is I wanted to set the input type for this keyboard. How did I know I wanted it to be the input type? Well, I went out to my activity main XML, and I found an edit text that we already had on there. I clicked on it, and I looked at the different input types that are here. Well, I saw input type, and if I click on input type, here's all the different options I have. So here's there's a number signed one. That's probably the one I actually want, but I'm not going to worry about that right now. But in any case, I knew I wanted this property called input type. So because of that, when I went back into my code over here, I said, okay, I'm going to take my edit text. I'm going to try. I figured, okay, I'm setting something. So I'm going to set the input type. So I used the command completion to kind of figure that out. Now, if I go and pretend to do that again, so I'll say temp et dot set input type. Notice the input type takes an integer as a parameter. So this is pretty common in libraries that are out there. Now, realistically speaking, and I think if you saw you'll see it here when I type it in, I think the number associated with the keyboard that I picked is number 2. Okay, but we're probably not going to, we just saw there was a list of, 20 different keyboards that are supported. You're not going to have memorized in your head that keyboard number 7 is this kind of keyboard, and keyboard number 8 is this kind of keyboard, things like that. So it's pretty common in various libraries for them to have a static class. Well, a class with a bunch of static fields in it that allow you to say the name of something. So this guy's going to be, I'm setting the input type. And then what I did is once I was in here, I made a guess. I said, okay, well, I'm going to type in input type. Okay, so here's this class called input type. Because I need an input type, so there's probably a class called input type, and I'm guessing that this class is going to be filled up with a bunch of class fields. So I'll say input type, and then I'll press that, and notice I have a whole bunch of, a lot of times, static fields like this, they're probably static final fields. They're on all caps like this. So this allowed me to go through and select it like this. So I wanted the class number. It's showing me that it's actually equal to a 2, so I could just hard code a 2 in here if I wanted to. But first of all, choosing type class number allows it to be future-proof in case at some point in time they make an update and they actually change the numbers associated with the keyboards. It'll still work, stuff like that. But this is a pretty common approach to having values for inputs to functions. To have a class filled up with static ints or something like that represent the kinds of values you want. All right, so I'm going to make another guess here, actually, for that negative sign while I'm sitting here. So I'm going to do a mask. So I'm going to say I wanted to input type number, and then I'm going to bitwise OR that with input type dot. I'm going to do my flag signed. All right, let me try that first and see if that works. This is another kind of common thing for getting types set up, is a lot of times you bitwise, you mask them together using bitwise ORs. This kind of gives you both options. I want a number keyboard that is flag for signed. So let's see if this gives me the behavior I wanted. Otherwise, I'm not going to spend, it's probably a Google search away, but I want to focus more on the loads and stores. Yep. So that let me do it. All right, so again, this is more from past knowledge of probably nothing with keyboards, just a lot of times the way they let you, when you have libraries that let you do things based on a numeric input, you can have multiple options associated with it. You can bitwise OR together to accomplish this kind of stuff. It's nothing to do with Android. You can find C libraries that are 20 years old that probably work the exact same way. All right, for having options. All right, so in this case, you just put in all the different types that you want to have that would be compatible with each other, because you're going to get some pretty weird input if you do like type class number ORed with type class text. You're going to get some sort of very strange Bigfoot type citing keyboard that might not even be a renderable keyboard. It might just crash and say this isn't a number. It's not a thing, but this guy gave us both. So now all of our edit text will be able to do numbers that are signed. It is weird that class number wouldn't be signed by default, but I suppose that makes some sense that you might want to have just positive numbers and not let them hit the negative sign. I just would have thought that in that case, the keyboard just wouldn't have the negative sign in it. Because typically, if you have an app that has a keyboard that pops up, you kind of expect all the buttons to work. Isn't that a true statement? Like if it's not going to work, there shouldn't be a button. It's kind of the thing, but yeah, whatever. It's a thing. All right, so we create our edit text here. Then we go ahead and give ourselves a brand new text view that we're going to put. This is our label for, this is bucket 0, bucket 1, bucket 2, bucket 3. So that's our count for bytes. So we'll change the font here a little bit in a second, or center it or something like that. But the idea is this is byte 0, this is byte 1, byte 2, all the way up to byte 63. All right, because we're putting things in memory here, and then we want to be able to save that memory. So we're going to have to do something with our global singleton that we have somewhere in here. What do we call that? AR map? Yeah, I think AR map. R map. Like that. All right, so in any case, we can put all these numbers in here. These are our labels. These are the values that are going to be at those labels. Now, right now, this is all just visual, right? So we have our edit texts. We have our labels for those edit texts. Then we're creating a horizontal layout to store those guys. That way they stack next to each other. All right, so I add my label first, then I add my edit text. So this right here is a horizontal vertical linear layout. I threw in this label first, this text view, then I threw in this edit text, and it has these guys right next to each other like this. All right, and we can try to organize it better, make it look nicer, whatever, but let's not worry about that right now. Okay. Now, ultimately, I'm going to, when I put a -3 in there, like at bucket 0, and I hit save, I want something to happen, right? I want my memory to actually change, just like we had our registers change. So I'm going to need to have a way of storing memory. So again, we're going to put this inside of our global AR map thing. So we already have our registers in there, right? Okay, so our registers is an array of registers. Now, for starters, how do we represent our memory? Are we going to have, do we need memory to store things in binary? I don't know that we do to accomplish what our simulator is supposed to do. Because the idea is that we would store values from our program. So we might store something that's currently in a register into memory. We might load something from memory into a register. When we view those things, we are viewing them in decimal, right? But only when we click on detail on a register do we see the binary version of those things. Do we ever need to see the binary version of something that's in memory? I don't know if that's going to be all that helpful for us. So I think we probably can store memory as just a collection of integers. That's fair enough. Okay, and we can always upgrade it later if we decide we want to do it differently. All right, so we'll have, this is inside of AR map, we'll have a public static, and we're going to just make an int array. All right, and this int array is going to have a, what do we want to call it? We want to call it memory. This would be a new int array. Now we can say 64 here, like that, if we want. What might make more sense, or might be a little bit more expressive, is maybe at the top here, we have maybe final, we create some final fields, and maybe we do something like a private static final int memory size is equal to 64, something like that. So then in here, what we would do is we would say AR map dot memory size. Now, if you really wanted to be organized, we might want to create a almost a configuration class that was maybe a simulator config that had a bunch of static stuff in it, one of them being final int memory size, so that if you wanted to change the amount of memory that you had in your program, you would just change it in one place like this, and then it would, this guy would get built as an array filled up with more stuff. Now, similarly, we can probably go ahead and inside of init, initialize our memory with a bunch of zeros. Kind of that's what we did with our registers. So, I hate this keyboard. So I'm going to put a little comment here. Let's say initialize memory. I'm going to say arrays.fill, and I'm going to say armap.memory, and I'll fill it with zeros. Have we used arrays.fill in here before? I think so. Okay, so it's just kind of a convenient way to fill up an array with a bunch of stuff. If you don't like using the shortcut, you could just say for int I equals 0, I is less than armap.memory.length or armap.memory size, I++, and then just put zeros in each bucket. So if you didn't know about the arrays thing. All right. So then realistically what we do here, now that we have memory represented as an integer array of size armap.memory size, and we have it filled up with initially zeros, but potentially other stuff later on, what we'd want to do is inside of our memory screen, we wouldn't necessarily hard code this to 64. We're going to create enough memory for armap dot. Oh, hold on, did I make that private? I didn't think I did, but I might have. Yep. I need to make this guy public. Or I could have just used memory.length. So I could decide which of those. This is final, so it doesn't matter. So I'm going to say AR map dot memory size. So that's how many edit texts I'm going to make. I'm going to make memory size number of edit texts. Okay. And then I'll go ahead, instead of setting the value to 0 here, I'm going to set the value to the empty string concatenated with armap.memory at bucket I. Okay, we're doing this inside of onCreate. So that's going to load in whatever the current value stored in that integer array is. So initially, the first time I come to the screen, it will be a 0. But future times I come to the screen, if after I set some stuff, it might be different values. If I did some saving. All right, that makes sense? Okay. So I'm going to do that memory size number of times. I'm going to initialize each one to the current value associated with that. Okay, oh yeah, this is our thing. Store in an array. We just did that. Okay, so now I need to create my function for saving. Correct? All right, so I'll go ahead and create my function for saving. So I'll say public void on save button clicked or whatever view v. All right, now when I hit save, what do I need to do? I need to go through all my memory and save the current values that are currently in those text boxes, those edit texts rather, to the corresponding place in memory. Well, the problem is right now is I built all these edit texts on the fly, but I didn't actually store them anywhere. So I don't have access to those guys. So I'm going to need to give myself a local array of edit texts of size, memory size, so I can store these dudes. All right, so I will create a private edit text array, and we'll call this guy the memory ETs. Okay, and this guy will be a new edit text array of size armap.memory size. All right, this makes sense what I'm doing here? So I already have inside of my singleton an integer array that's holding the values of memory. Now I need to have a edit text array that holds all of my edit texts that correspond to those values in memory, so that when I hit save, I can go ahead and read any changes I made and overwrite my actual values in memory. Okay, so that means each time I create a edit text right here, I'm going to say save to the memory ETs. So I'll say this dot the memory ETs at bucket I is equal to temp ET. So I'll go ahead and store that particular edit text before I overwrite it the next pass through. Because edit text is a little temporary variable I have here that each time through I set to a new memory address. So before I overwrite it, I'm going to preserve it inside of my array of edit texts. That make sense? Okay, so now I have access to all my edit texts as I'm building them before I overwrite that pointer. Let me ask you this. So Java has automatic garbage collection, right? What does it mean for Java to have automatic garbage collection? When I say that, what does that phrase mean? Go ahead.
When it determines that you are done using a variable, it will read that variable from memory.
Okay, so you're correct. So specifically, when it determines that I'm done using a specific bucket of memory, which is associated with a variable, right, then it says I'm going to go ahead and I'm going to the automatic garbage collection pieces, kind of like a virtual garbage truck comes by and cleans up that memory, releases it to the operating system so it can hand it out to somebody else, right? And Java does that for us automatically, okay? Whereas older languages like C or C++, we would have had to delete or dealloc memory ourselves. Now, you mentioned that when it determines that we no longer are using a piece of memory, that it will clean it up for us. How does it determine that we're no longer using a piece of memory? Go ahead.
Is that there's no pointers pointing to it?
Okay, so determines that there's no, so how does it determine there's no pointers pointing to it?
Doesn't it have a counter?
Have a what?
Doesn't it have a pointer counter?
Yeah, so there's going to be a pointer count. So every bucket of memory is going to have a pointer counter associated with it. Where not every bucket of memory, it's going to be every allocated bucket of memory will have a pointer counter associated with it. All right, and that pointer counter starts off at, when you first allocate it, will start off at a 1. Because at that point you have something pointing to it. So at that moment you have exactly one thing pointing to it. All right. So when we first create new memory here, new edit text, temp et points to a place in memory that is returned by this constructor. Therefore, the pointer count for that guy will be a 1. Now, the next time through here, I am overwriting temp et with a new memory address, which will decrement the pointer counter for the previous memory address. When I add this guy here to my array of edit texts, its pointer counter goes up by 1. Because now, right after this line, there are 2 separate things. Point to the memory that is stored in temp et. Okay, so 2 different things point to the memory that is stored in temp et. Temp et, as well as bucket I of the memory ets. Make sense? So 2 things are pointing to it. So its pointer count is currently 2. The next time through this loop, when I overwrite temp et, the pointer count for that bucket of memory goes from 2 down to 1. So it's not garbage collected. Okay, because I still have a pointer to that place in memory that I preserved inside of my array. Now, the reality is it actually wasn't a pointer counter of 2. It was actually a pointer counter of 3. Because before I did this, did our edit text still work? Who else pointed to them?
The edit text on the screen.
Yeah, so, well, the edit text on the screen, which this is the variable version of it, but those guys were stored in a collection inside of our view group. So the view group held a collection of pointers to the actual edit text. So there was a third guy that we didn't really have, well, we had some control over. It happened right here. So we kind of threw our edit text into another collection somewhere. I don't know behind the scenes if it's probably doing that as a linked list or some sort of list type structure. But when I added it to my horizontal view group, we got another pointer to that dude. All right, so that's why they didn't disappear on the screen. That's why we didn't get crashes and things like that, because even though we counted down to 0 here, we actually went from 2 to 1 when we overwrote temp et. All right, but now we're preserving it programmatically so that we still have access to that dude. We actually could have still accessed it using our horizontal VG. So our horizontal view group, we could have gotten the views from that guy, his collection of children, walked through it, asking each child, are you an edit text? If you're an edit text, then I'm going to get your value, something like that. So we had kind of an indirect way of doing it, but that horizontal, actually, we could have walked through our memory VG, that top level view group, which is our the vertical linear layout inside of the scroll view. this guy. We added that horizontal VG to him. So we could have gone through every view inside of memory VG, and that's going to be a collection of horizontal view groups. Then ask each of those horizontal view groups for his list of children. Then look at that list of children and find only the ones that are edit texts, because we're going to have text views and edit texts in there. And then say that, that's our edit text we want to read from. Or we can just create an array of the edit text and directly access it. Just saying we could have gotten to it the other way as well. All right, but we're going to go ahead and preserve it in a nice flat array here that just holds edit text, where bucket 0 of that edit text array maps directly to our edit text in memory. For value in memory, bucket 0 of memory references bucket 0 of our edit texts, so on and so forth. Okay. So this is where we are giving it the current value. So the default value would be 0. Otherwise, if this is the second, third, fourth, whatever time we visited the screen and we've previously saved memory, we might be loading different values into our edit texts. But any way you cut it, we are storing our edit texts here. So then on save button clicked, we want to go through all of our edit texts and overwrite the same bucket in memory in our integer array with the value, the integer version of the value that's in our edit text. Now we are presuming that they didn't backspace out any of the stuff, and there's always going to be numbers in there, but we don't have to error check that. Probably should, but we won't. All right, so I'm going to go through all my edit texts. So I'm going to say for int I is equal to 0. I is less than. Now I have some synonyms here, right? I can say this dot memory ETs dot length. I can say AR map dot memory size. I can say AR map dot memory dot length. All three of those numbers should be the same because they were all built using, well, the two arrays were built using AR map dot memory size. But I'm going to go ahead and just use the generic AR map dot memory size, because that really spells out what we're trying to accomplish here, right? We are going through memory and we're marrying these two arrays, edit text and our integer array together. Okay, so now what I want to do is I want to overwrite bucket I of AR map's memory with the integer value of the edit text at bucket I in memory ETs. So we'll say AR map dot memory at bucket I is going to be equal to a new value. That value will be equal to integer dot parseInt, and the string that we're going to put there, or the integer we're going to put there, is going to be the integer version of the string contained in the edit text at bucket I of AR, what do I call it? Memory ETs? The memory ETs. So this dot the memory ETs at bucket I dot get text dot toString. So I'm saying take this string, turn it into an int, store that int in my memory array. Make sense? All right, so that's what we do on the save button. And then I think on the other screen, didn't we also have it go ahead and exit, go back to the previous screen? Okay, so after we've done doing all that mapping, how did we do that? How did we go back to the previous screen? Anybody remember? Go ahead.
Well, there's a couple ways you can do it, but the best way to do it is just to call the finish method.
Okay, yeah, that's not the way we did it in the previous one, right? Yeah. So we could say this dot finish. Yeah, so this actually tells this particular activity to complete. And when that happens, that does memory cleanup and then also kicks us out. All right, so actually this is, it probably is the best way because it probably is doing some cleanup stuff anyways. But
what I've seen is being recommended.
Yeah, right. But one of the things this guy is doing, we'll leave it like this, but let me just show the other way just as a reminder. What we had done before is we would say this dot, what was it, on back button? on back pressed. You can say that. So call this guy's on back pressed function, which ultimately is his parents' on back pressed, which will just kick us back to the previous screen. All right. And if we chose to override that on back pressed function, we can do other things when that back button is pressed. We can choose to do that. And I believe that this dot finish does call that method. I want to prove that just for a second here. Public void on back pressed. So I went ahead and overrode the on back pressed function. I just printed out called by finish, because I'm hoping that when I hit save after it does this stuff and I call finish, part of what finish does is it calls the on back pressed logic. Now, if it doesn't, that means that on back pressed must call something else that finish also calls. So we'll see if they call each other. The deal here is whether or not you can put stuff inside of on back press that you want to have happen when you leave this screen, whether you're leaving it based on a back press or you're leaving it when the activity finishes. Based on that, I'm actually going to guess it will not print this. I'm thinking the things you put in here would only happen when you actually hit the back button. That finish would not actually call on back pressed, but it would probably call the aspect of on back pressed that gets called to take us back to the previous screen, which may actually be finish, potentially. All right, but let's just see. Yeah, but I don't think this is going to get called. When we do this dot finish, I don't think it'll print this out, but we'll test it since we already wrote it. Yeah, I'm not using it right now, so we'll go in there, we'll hit save. Actually, it's not going to do anything right now because I didn't actually hook up the save thing. So we go to my activity thing here. I'll click the save button, click on click. Here's my on save button clicked. Have that guy cooking. All right, so now I'll go into memory. I'll go ahead and just hit save, which should finish, take us out of there. I'm going to open up logcat. And I'm going to do a search here for some asterisks. And I'm going to look at verbose. Yep, does not look like, actually I can look at system.out. Yeah, nothing printed out. So does not call it guy. But if I go back into memory and then I hit the back button here, it does call the guy. Okay, so after we hit our save button, we'll go ahead and finish. Memory should have been altered at that point. So if we came back in, we should see updated memory. Let's just test that here. So I'll go to memory. I'll change this first guy here to a 3. We'll hit save, goes back here. If I go back into memory, we should see a 3 there. All right, so memory is now getting saved. Okay, so remind me. how loads work. So what's the load function? I think the one we've looked at is LDUR. Well, I think it showed multiple ones, but this is load, what, unsigned register? Is that what the U stands for?
Yeah.
Load unsigned register. So this will, so what does load take as parameters? What are the inputs to load? Go ahead.
It will take a register that will store the end result in.
Yep. Let's call this dest register. And what else?
It takes a address to look up in memory.
Okay.
And it takes an offset from that address.
Okay. That's all kind of in one parameter though, right?
Yeah.
So if we look up memory address, this guy, so here, maybe let's call this offset, memory address offset, something like that. So what does that memory address offset look like? What's the syntax for it? So I think it looks kind of like an array type thing, right?
Mm-hmm.
Okay, and it takes a base address. And what's the base address?
Usually register where it's going.
Yeah, another register. Okay, so in fact, I think LDUR, I think it has to be a register. I don't think you can give it a literal value. So this is going to be a register base address, and then comma, and then offset, literal, something like that. So we could do something like load into x1, x2 offset 4, something like that. So that will go, that'll put into x1 the value that lives in memory, starting at position x2, taking 4 byte steps away from x2. So let's say x2 was currently a 3. So this would be x2 is a 3. It would take 1, 2, 3, 4. So it would give us this value right here and load it into x1. That makes sense? All right, so we need to be able to decode an instruction that looks like this. So we're going to add load unsigned register to our code base here, where we are going to require you to put a base address somewhere. So it'll be, in our world, it'll be a number between 0 and 64. Okay, and if you're going to put a 64, better keep your offset low. Take no steps. Okay, so you could say offset 64 0, right? Which means you're just going to bucket 64 and stopping. But yeah, otherwise you walk off the end of memory, and then your system doesn't have enough RAM, and add more RAM, which is easy enough for us to do. We can just go and update that. Let's go in here. Where's this guy? Yeah. Just change this to 1024, and we got a lot more RAM. Good to go. Good to go. So we have a pretty easy way now of expanding our RAM without too much hassle. Okay, so we need to go back here to our, the idea here would be, this guy might say load unsigned register x1 comma x2 comma 4, something like that. Is that legal syntax for load unsigned register? Looks like it. Okay. This is a comma, not a colon, right?
I believe so.
Let's triple check.
I think it's unscaled register, not unsigned.
Unscaled?
That's some things I've seen online. Unsigned doesn't make sense.
Is there a signed version of it? You might be right. LDUR. I thought there was a signed version of that. It seems very assembly languagey for there to be a signed and unsigned. Instructions in here somewhere.
Oh, yeah, unscaled offset.
So unscaled offset means take a step of 1, as opposed to is there a scaled offset?
I'd imagine so.
What does that mean? Is that like taking larger leaps? Too many magic tricks, I tell you what. All right. So, but was our syntax right with the comma?
Yes.
Okay, good. All right, so this is reasonable syntax for what we want to do. So now we're going to need to be able to parse this instruction, right? So we're adding to our instructions here for this guy. So we are handling our instruction inside of instruction, right? So when we hit execute, we are looking at a particular magic trick. So here's our thing where we're splitting our instruction up. So we figure out where our first space is in our instruction. That's going to be the space between, let's see, actually when we do, that's the first space here, the space between our actual instruction and the stuff that comes after the instruction. All right, so that's where we get our magic trick. So it's going to be from bucket 0 to location of the first space. Do I trim that at some point? Probably should be trimming. Oh, actually, am I trimming the instruction when I pass it in? I hope I am. This will be another good example of coupling if we're not. I'm not. All right, so right now we could have an issue where if we have a leading space before our magic trick, we don't actually correctly identify the magic trick because we are getting our magic trick right here where we're saying I want the instruction dot substring from bucket 0. We're presuming bucket 0 is where the beginning of our instruction is. Okay, where it actually is not necessarily there.
So first non-space.
Yeah. So the best way for us to handle that is to not have coupling. See, we can decide that we can trim it in the other place and then send it in here. But now we're reliant on logic that's in the other place. We should handle it all right here. So whatever instruction they send us, we'll just go ahead and say instruction is equal to instruction.trim. Now we're guaranteed that bucket 0 is the beginning of our instruction. That makes sense? As opposed to having something that look like this. Space, 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 add, blah, 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 whatever. If that was the case, so if I said add x1, comma, x2, comma, x3, something like that, the instruction, the magic trick would have been that string. A bunch of spaces followed by the word add. But if I trim it first, trim will take those spaces out and will also take these trailing spaces out. So it trims all the white space off the ends. Okay, so now we're a little bit more correct than we were before. Go ahead.
Two things. One, would it possibly be more advantageous to, say, get the position of our first alphabetic character and then go to our first space? That way, if they begin with a quote or something, we can kind of ignore that because they didn't mean to type that.
Yeah. I mean, at that point, we're probably talking about adding error checking.
Right.
Because we probably wouldn't want to let them start with a quote. We probably want to scream at them, probably make some toast.
Right.
All right, so I mean, you're not wrong. That's not an incorrect approach, but since we're kind of assuming perfect input,
right.
Yeah, let's trim it and just say instruction started at bucket 0 now.
And then second thing,
Mhm.
I found the difference between scaling and unscaled.
Okay.
So the offset doesn't have to be a literal. It can be another register or an instruction. So when you scale it, you give it a instruction and then a register that holds the offset and an instruction that gives a transformation to that register.
So the result of an instruction.
Right. So unscaled, it has to be a untampered number if it's a number literal.
Yeah.
or
I wonder
something.
why scaled is the word being used.
Because shifting and multiplication.
Yeah, well, I'm just thinking that, like, why is there a difference between, I mean, you know, we've used like add and add I for immediate versus, you know, so add requires a register, add I requires literal, right? So if a normal load has an offset that's represented as a literal versus a load, so LDUR, what's the other one?
The other one is LDR.
LDR. That one allows us to have, that one's scaled, but requires either a register, which might hold a literal, probably hold a literal. I think must hold a literal. So a register or the result of another instruction. I'm guessing there must be a very specific set of instructions.
Yeah, probably.
That would be allowed to be put there. Yeah, I don't know why the word scaled is used. That's just I'm sure there is a reason. Just
yeah, probably has to do with tensors or something.
Probably. That's an interesting question. So following the hackathon, which I think was pretty fun, right? Can anybody now you've had some experience using TensorFlow. Can anybody actually tell me what a tensor is? It's like I thought it was just a cool name. All the way at the bottom of the code, the sample code, where they were feeding it one-offs, they were feeding it tensors. So what tensors is kind of a really fancy name for what? Go ahead.
Well, this might not be the definition you're going to use, but I'd say it's kind of a multi-dimensional vector. So a vector is position and magnitude, or not position and magnitude, rotation and magnitude in one dimension. But a tensor kind of has multi-dimensions. So if
can have multi-dimensions.
Right.
Yeah.
So if you're like scaling something up or mirroring something, those sorts of transformations are tensor transformations as opposed to translation, which is a vector transformation.
Okay, so at the end of the day, tensors are really multi-dimensional arrays where the smallest dimension is 1. It's just an array that holds a bunch of input values and a desired output. So it's a kind of a really fancy way of saying, I mean, what you're talking about is correct. It does imply certain things about matrix transformations that play into this. And one of the things you saw in the sample code was it talked about the shape of the input. And I think the example we had, the shape was 4, nothing, because it was a one-dimensional array with 4 inputs, 4 buckets. That was the tensor that was coming into that particular model as an input. Yeah. So in any case, that is just when you mentioned tensor, it popped in my head. Okay. So we need to make sure that we don't need to doctor up our split here. Is it still working? So now we'll trim up our instruction. We find the location of the first space. We grab our magic trick. I think we're okay to here, right? So that'll get our LDUR in our magic trick. Okay. Now we need to get the rest. So the rest is our instruction. substring from the location of the first space, trim, so get all the extra spaces off the end. Although I don't think we would need, actually trimming is necessary here because you potentially might have somebody who puts extra spaces after their magic trick before they get to the stuff. So we'll trim that. This is the string representation of the rest of the stuff. Now we want to get the parts of this. And this is where things might get a little bit weird for us, because before we were looking at something that looked like this when we did the split. All right, because we might have had this was like an add instruction. So add x0, comma x1, comma x2. But now if we're doing something like, just backspace this. Now if we're doing something that might look like x0, comma x1, comma 4, something like that. That might be what my input looks like. And I am splitting this guy on commas. I'm going to get 3 pieces. I'll get an x0. I'll get an x1, and I'll get a 4, like that. So that'll be my split. Okay, so can we work with this? If this is my split, where I know my, so this is our destination name, and then we've stored it inside of our input names. So we're still only getting 2 inputs, right? I mean, this guy is similarly structured to a, actually, this is not similarly structured to add. This has 1 less input as far as this guy's concerned. Actually, no, it'll have the same number of inputs as far as this guy's concerned, just they're a little bit uglier. So us calling it destination name, that part's accurate. We're good with that. But input names aren't quite accurate for this guy, because really our second input is this guy, which is going to be a base address, and then this guy here. So we might want to parse differently depending on the kind of instruction we're looking at, right? So all these instructions work for adds, subtracts, add I, subtract I, and probably works for a collection of other things as well, right? But wouldn't we parse this guy differently? How could we parse that guy? We're still going to have to do it on commas, aren't we? Like right now, if we're just trying to use these inputs, destination name is still the correct variable name for that first part. X0 is our destination, right? But these input names, these guys, that's going to give us this square bracket X1, and then that's going to give us another number followed by a square bracket. Is that okay for us to store those inside these 2 input names? We can still doctor those up internally, right? We potentially might be going down a questionable path, but this is changeable internally. At some point, as we start giving ourselves a bigger and bigger and bigger instruction set, we might want to sit there and say, okay, well, this collection of instructions are parsed this way. This collection of instructions are parsed this way, something like that. But at this point, we haven't necessarily deviated from what we need here, other than the fact that we have some extra goo kind of attached to our second values here. Okay, so if we still go down to our magic tricks, so let's do a else if this dot magic trick dot equals ignore case, and this guy is going to be LDUR. If that's the case, we want to go ahead and do a little bit more doctoring of our stuff. Now, destination register, I think we can just use that code, right? We still want to just get our destination register. And again, I think we said this before, we can reduce the duplication of some of these lines since we're always getting destination register and stuff, but let's just keep it separated like this for now. Okay. Then we need our base register. So I'm actually going to steal, we're going to say the base register we're going to use here is the register named that. Okay, now notice that we are trimming these guys. So we are guaranteed right now to have our base register to look like that without the comma, this guy right here. So how do I get everything from that except the opening square bracket? Go ahead. Well, you could write a remove char. I think there's a string buffer that would allow you to remove a char too, but there's a cleaner way. So not incorrect. You could do that. Just say, look, I'm going to doctor this guy and just remove the stuff I don't want. Certainly an option. Any other approaches? Go ahead.
Use substring, just putting one at the beginning.
Yeah. Tell me where to start and give me the rest. So what we can do down here is we can say register base, call this base register, holds the base address. I think it's fair enough. And this guy would be equal to armap.find register with name. And the name of this guy will be the input names dot get zero. Now I want to make sure I'm not reading these backwards. Okay, I'm getting them in the right order, the order in which we're hitting them. Okay. All right, so the input names dot get zero. So this will be that square bracket name of the register. So I'm going to say this guy dot substring 1. That says give me everything from bucket 1 forward. Ignore bucket 0. All right, so that should get me that register. All right, then we're going to have our int offset is going to be equal to, now this guy looks like this right here. So a number followed by a square bracket. So I want everything but the square bracket. So how do I get everything but the last character? I use substring again, but base it off of its length, length minus 1. So I'll say int offset is equal to armap.find register. I'm sorry, it's not find register with name. It's going to be integer.parseInt because I want to get a number out of this. And that parseInt is going to be the input names dot get 1. It's going to give me a string dot substring from bucket 0 to bucket. Probably want to store this in a place real quick. Just say string temp is equal to this dude. So this will be temp dot substring from bucket 0 to temp dot length minus 1. Everything but the last character. All right, so that'll give me the integer version of that number without the square bracket on the end of it. So that gives me my offset. All right. Now that I have the register, my destination register, I want to set his value equal to the value in memory that is equal to the value of base register, which is a number, right? Plus, okay, so we'll just type it out here. So I want to set destination register dot set value. Actually, let's do it in a couple of pieces rather than do it in one scary line. All right, so we're going to say, geez, I did a lot of damage in that one little click. I really hate this mouse. My hands are too fat, I think. Or I'm sure it's the technology. It's crap. So what I want to do is I want to get the base address value, right? So int base address value is equal to base register dot get value, and that comes out as an int. So now I have that value. This is going to be my base address, so some bucket in memory. Then I need to get my offset, which I already have. So I want to add that base address value. I want to add to that my offset. And that's going to give me a bucket. So int final memory bucket is equal to base address value plus offset. Make sense? So that took me to a base address. I added offset to it. Now I'm sitting at a bucket in memory. So now I want to get the value from that bucket and I want to put it into my destination register. So destination register dot set value equal to armap dot memory at bucket final memory bucket. That makes sense? All right, and is that what a load does? Okay, so a load says this is where I'm putting it. This is where I want you to start. This is how far I want you to walk from there. So now we'll get the value from where we start. We'll add to it the offset, getting our final bucket in memory. Take that value that lives in memory, which is an int, and set the value of our destination register equal to that. Okay, let's see how this guy works. So I want to go to my activity mains. We can type in a new instruction here for testing. So we'll say LDUR x1 x2 comma 4, something like that. Okay, so we need to make sure we put a value in x2. And then we also need to make sure we put a value in 4 off that base address so that we prove the lookup. Okay, so first let's go to our registers, and we're going to say we're going to have a base address in x2 of, let's say, 5. Okay. All right, then I need to go to memory, and we're going to start at 5, and I want to do an offset of 4 from that guy. So 5, 6, 7, 8, 9. So let's put a, I don't know, an 11 in there. Okay, so now if I execute this, it should put into register x1 the value that lives at x2 plus 4, which should be an 11. So after I execute this, I go to registers, and my x1 is an 11. All right, so we wrote load. So guess what you get to rate for homework? Store. Okay, so you have your memory, you have all that jazz. Let me commit and push. So is written, you must write, what is it, ST, is it STUR?
Yeah.
Create and commit and push.
Looks like we can also get our address from a stack pointer.
Well, we don't have a stack yet. So no, you can't. Our architecture does not support a stack, so you must get your address this way. All right. Questions, comments, concerns, bribes. Code is up. I'll put the assignment up. I'll put another link to the code in there for the GitHub, just so you have a refreshed version. But it's the same code we've been working with. I'll see everybody on Thursday. I'll also get Bible homework up here in the next 5 minutes. I'll put all that up now. All right. I'll see everybody on Thursday.